All right. So today's experience sharing session is about functional programming. Well, not all of the functional programming, but like very superficial layer of it. So, but before we talk about what it is and how it works, I want to ask you what's object-oriented programming.
It's a paradigm.
Paradigm of what? Of life? Can you live a life in a way of object-oriented programming?
Yes.
That's a good question.
How one lives a life in an object-oriented programming way?
I've heard that there's this psychological type of a conscientious person where like the person wants to have stuff in a box that's in a box of other boxes and so on.
So you are saying that I should really make this my object-oriented programming class next semester. I should make it cross-listed with psychology.
Yes.
So all of you can get social science credits. I'm sure you all love social
Because we're all
science credits.
physical people.
Yes, but without jokes aside, what's object-oriented programming?
Programming that's based on creating objects, classes, and everything.
So creating objects and classes. And what are objects and classes?
So if class
Is a template. Object is created through this template.
Sure. Template of what?
it's basically how object should be created, like schema of it, you have fields.
Okay. Can everything in programming be objects? Can, for instance, I don't know. So everyone join Zoom. I can erase it. Cool. Is this an object? Is 5 an object? Is int an object? Is A an object? What's an object? Can you define object without using word class?
In JavaScript, yes.
I was going to say.
No, in pseudocode, with no connection to any concrete language. What's an object?
If you say English translation definition, it's just anything that can be seen or sensed.
Seen or sensed, and also what it should be? It should be somewhat different from the things outside. So, for instance, why this is a part of stool and this is not? Because this is shaped the stool and all around it is an environment. So the idea of object-oriented programming is that we divide things into entities. Have you heard that word before? Entity. Right? So stool is an entity, table is an entity, laptop is an entity, human is an entity, weather is an entity, air as a concept is also an entity. Right, so we divide that into entities, and also sorry for my accent, as you all know I have A2 English, and like every time I teach a class I speak English for the first time. Everything is divided into entities. And we work based on that. So we try to find some different connections between entities. So for instance, what kind of relationship between objects you know? So you have two objects, what they can be between each other?
Parent and child.
They can have a part of inheritance, yes. So one can be parent, object of a parent class, another can be object of the derived class. Good, what else? Again, good. One object observing the behavior of another object. Good, that's an observer pattern. Anything else? Actually, quickly, in groups of 2, come up with 2, 3 in small groups. Come up with like 5 different relationships one can have between objects. Like I will give you literally 90 seconds for that. Okay, as I see, it's a discussion. It's mostly that, so read discussion. What are the fruits of discussion? So aside from this,
And there is also like a factory pattern. One class can produce, one object can produce.
more design patterns here. There's a factory that produces objects of another type. Good. Anything else?
One object can use another object.
Look, one object can
Use.
how is it called? Oh, in what sense you use word use in this context?
One object. For example, to creating something, to changing something.
So how is it called when you have one object within another object?
It's
No, nested object.
whole thing, one whole thing and part of it.
Yes, but like what's proper name we have for that in object-oriented design?
What do you do there?
Let's play a game.
It's so long.
Letter I. There is an I. N. There is an N. O. There is at least two O's. Oh, there is also another I.
T.
Composition?
Composition, great. What's composition? Actually, and you didn't even lose like one part of the body. Rip me, I guess. Anyway, so what's composition?
You compose something by using some other objects.
So the idea is, for instance, if I have class course, and within class course I have object teacher and vector of object students. That's composition. So students and teacher are part of the object of class course. Yeah, so that's also very I'm sure all of you used composition in some project or another, or about to use them in my wonderful Uno project that I came up with, and I'm so proud of myself. Anyway, so as you can see, there's also much more design patterns. There's interface design pattern, strategy design pattern. So all the ways that different classes can interact with each other. So that's the idea of object-oriented programming. Now, can you guess what's the idea of functional programming? Everything done with the functions. How do you think it's done, German?
Well, it's instead of the functions, we have just do the job and
So the idea is what you can do with functions in regular programming. So far, what have you done with functions in your programming assignments for this university or outside of university? You can what?
Solve that problem.
No. How did you use a function or a method or coroutine, call it whatever you want?
You can pass arguments.
You can pass arguments to it.
You can put it into some label. You can.
That's an interesting part. So, but like how we usually declare them, we call them. That's all. That's how we use them. Sometimes we declare them inside objects, and that become class methods, right, and stuff like that. The idea of functional programming is treating functions as first class objects. So first class objects, it means that you can do with them everything that you can do with regular variable. So the idea is that if I can write, if I was allowed to write, int a equals to 5, or student s equals new student student already having Java file flashbacks, right? If I can write this, what prevents me from writing something like this? Int f. Actually, yeah, equals to, I don't know, min. What happens in this line of code? So, what's this that we have here? So, as you can see, there is an assignment operator. So, an assignment is happening. If an assignment is happening on the left side, you should have an L value, and on the right side, you should have an R value, right? So here it's a little bit different. Here both of them are L values. So let's try to figure out what's going on. So what's min?
It's existing function.
That's a function that already exists, right? So what min function does? Takes two numbers and returns the minimum of them. So we are saying, so what I'm saying here is that I create a function f, and variable f, I'm sorry, that is of a type function that returns an integers and then takes two integers as its parameters. What other functions satisfy this? Again, 90-second exercise. Come up with at least 3 other functions that will fit into this variable f. No, in groups.
I'm so creative. No, actually, those ones. Those ones? Yeah. Square root is also one. And it takes a couple. That's all the math functions I ever use with any regularity. Yeah, sure, there's like functions gives that stuff.
Exactly 2, right?
Mm-hmm, exactly 2. So let's give you 50 more seconds and then start here. So, what are the functions? Come on, who will be the first to say max?
Me.
Aside from max. GCD, good.
Power,
good. Factorial, what's the second argument in factorial? So GCD, power, something that's not mass.
XY coordinates.
XY coordinates. So for instance, how about function, I don't know, circle or something like that in processing? I believe it requires 3 arguments, but something like that. So it could be any function, something more maybe? GCD, power,
Line.
absolute value again, it's only one. Combined?
Line.
Line, here you go, yes.
arithmetic operations.
Yes, all arithmetic operations, right? So that, and the idea is that after you created this variable, you can call it because it's a function. So what will be variable r equal to 4? And if instead I write this, here you go. So that's the idea of functional programming. So that we treat functions as first class objects. So the idea is that actually almost all modern programming languages support functional programming in some way or another. So C++ is not an exception, Java too, and so on and so on. But the idea is that functional programming is a very, very big paradigm with its own way of life. So one cannot live can live in a way of object-oriented programming. There are definitely people who live in a way of functional programming. There is a lot of concepts such as pure functions. So what a pure function? What's a monad? Do you guys know what's a monad? What? You haven't heard what a monad is? It's just a monoid in a category of end-of functors. Come on. Anyway, yeah. So there is all of this, and today we are not going to discuss that because that's worthy not of its own 6th credit course. It's probably worth of people who are taking data structures with me right now. I told them that we have object-oriented programming, but ideally we should also have a second 6th credit course that's called object-oriented design, where we talk how to those design patterns that we mentioned and all of that. The same is here. So ideally it's like a 12 credit course worth of talking material. Today we will not be talking about pure functions, we will not be talking about how to write in functional way. We will be talking about how we can use existing functional approaches in C++ to write your programs, right? So how to dilute your object-oriented programming style with some functional programs. Well, and that leads us to our first exercise. So let me share Zoom. Okay. Let me share this. Wonderful code for you all. Let's delete all of this. So, this is a longer group exercise. Let's give 3 minutes for that. Again, in groups, I want you to figure out what this program does.
Should we know what accumulate does? Should we know what accumulate does?
No. You're not expected to. You're supposed to guess what it does.
Oh, it's like...
Yeah, but first discuss it and then tell me. So what the code does? It does magic. Well, it's written down up there that it does magic. So what's happening there?
Iterates through vector.
Yes, so since we see in begin and end, we can assume that we iterate through all the vector, right? Like in sort. If you ever sorted anything in C++, you know that you start from begin, you go to end. With sophomores, we haven't discussed the idea of iterators, because we have better things to do, I guess. But the general idea is that when we see begin and end, that implies that we will probably do something from the beginning to the end. Okay. Then we have some magical number 0 that's very helpfully marked by C line as a need. And then we have something that's called binary op. What's binary op? Is it a reference to Gangnam Style or something?
It's a function that takes 2 parameters.
Yes, so binary operator. It's function that takes 2 parameters. We also have unary operator, a function that takes 1 parameter. And then we have ternary operator, a function that takes 3 parameters, and so on and so on and so on. Also we have a thing that's called variadic operator. What's variadic? It's called like this. So yes, it takes variable number of parameters. So here we provide basically some vector, we provide some initial number, and we provide the binary operation. Well, that's very interesting, and we are going to see what it does during this class. We are going to return back to this problem. So for now, we are going to move to program 2. Actually, I can move like this. Okay. So look, this program computes an average. Oh, thank you. This program computes an average of a vector, right? So if I ask you to do that, how would you do that? Well, since we are on short time, I already written that because like it's super trivial. Like find an average of all elements in the vector. How do you do that quickly? In one line. Add all variables divided by size. That's what's happening here. Okay, good. And we have our vector, and if we check, there is our result, 14.9. But it's our standard, good old, even not all object-oriented programming, it's structural way. There is also this, the functional average. So it's a way to do the same, but using functional way. And if we see, the result is exactly the same. Come on. Result is exactly the same. So the question is, what happens here? Again, 90 seconds to figure out what accumulate function does. Actually 10 seconds, come on. 10, 9, sure. So it sums everything from first to last with the starting sum of init. Right? So the idea is that it just sums for us the entire array and then we divide it by size. Not forgetting to use double to not get integer division. So that's the first example of functional programming. So why it's called functional? Well, the idea is that here in accumulate function, what actually happens is that it applies a function on the vector. So one of the main things in functional programming, aside from this first class objects, is that you can send functions as parameters to functions, right? So the idea is that, for instance, you can say that take my vector and apply function apps to it. What that would mean? So if you write a function that takes a vector and a function apps, you probably would want to take apps and apply it on every element of the vector. That's purely functional programming ideas. So accumulate is a standard library function that does the same. The only thing that the function that it applies by default is a function plus. It takes two elements and adds them together. So, and it does it for every single pair of elements that we have. So basically, the idea is that accumulate function has this for loop inside. That's all. But why it's more convenient? Who can guess?
Maybe there's some internal magic that's done.
Yeah, so it's done by internal magic, and as a consequence,
Faster, efficient.
no, not necessarily faster, but
Compact?
yes, it's much slower code. It's literally one line of code instead of technically you can do that probably in if I really wanted to go for a slow number of codes, I would probably will need to do this, but it's still 4 instead of 1. And the idea is that functional programming works on completely different ideas from what we all do. So those who are taking SQL with me, which is all of you, except for
For me.
celiac, yes. So I was talking a lot in my SQL class that SQL is declarative. What does it mean?
You explain what you want. Do you describe what you want? And in imperative, you tell how.
Exactly. So here we just say, please sum all numbers for us. How exactly it does it, it's not our concern. This is imperative way. Here we say, please take this variable, add this to it that many times, and so on and so on and so on. Functional programming works on the idea that since everything is function, so for instance, when you pass something to a sine function in math, are you so for instance, if I would ask you to find sine of 54 degrees, what would you do? Right now, find the sine of 54 degrees.
Siri, what is the sine of 54 degrees?
Sine, sinus. Yeah.
Yeah.
Oh,
I was gonna
ChatGPT
say,
was
I-
sine of 54
I was
degrees.
gonna get a
Yeah, so
calculator.
you can ask ChatGPT, you can open calculator. So you don't actually imagine a circle, and on that circle you like, okay, let's see, it's 54 degrees. Now let's use Pythagoras theorem to calculate sine. You do not do that. You just like, I want sine of 54 degrees, and your calculator says you, here you go. Imagine that instead of that, they would be like, please draw me a circle, and based on that circle, oh no, the circle you're drawing is not a circle enough. You need to try harder.
Your circle is missing a semicolon.
Your circle is missing a semicolon, yeah. So the idea is, that's why in regular math we are not doing that. We just pass things to a function. RIP. Can someone pick it up? Thank you. We pass things to a function, and the function does stuff for us. That's the idea here. So instead of saying that like, oh, do this for loop, we just say accumulate, and then we divide by size.
The same with roots, for example, right? For example, to calculate root of 2, square root of 2.
Yeah.
You don't know what's happening in the background.
Yes, exactly. Okay, what will be 5 times 4? How do you do that? Do you do 5 plus 5 plus 5 plus 5? Ah, that's 20. No, you have it somewhere memorized. So basically, a function in your brain that is multiplication immediately returns you a result. Okay.
That's another int function.
We are also computer.
Yes. So let's now look at example 3. So let's start with running main. I believe I have everything prepared for it. So, okay. So can you guess what program does? I have provided it with some file, actually with CMake list from this project. And it calculates how many lines it has there. And here we have several ways of doing this. So let's see. So first of all is empirical one. So let's see. So this is, don't worry about it, it's in order for the same file to be read by 3 different functions. So the actual function starts here. So we take our line count, we start to get every symbol in the file, and until we reach, and when if we see that the symbol is a new line, we are like, aha, we found a new line count. And then we return the result. So pretty simple stuff. Any questions about empirical count? Okay, so we do that in empirical way. Now let's see functional way with accumulate. Actually no, let's see functional way with count first. So again, don't pay attention to the first 2 lines. This is the only line of the method. So what does it do? So again, it has really weird iterators, right? So, but basically, we have first and last. That means that we go from the beginning of our vector, in this case of our file, to the end of our file. And then we provide with some value, in this case, new line character. And what count does? Counts how many of these values exist in this vector. That's all. Again, instead of all this, we have only this one line. So that's the main idea why the people who are not hardcore functional programmers who can say monad is a monoid in the category of end of functors and explain every word in that statement. So why the people who are not of that kind still might want to use functional approach, because it's much shorter, especially in languages that are not like C++, where you have to write this monstrosity. Instead, in Python, you could probably be just like, and that's all. And that will be much faster than this. So, and then we can see so any questions about this functional count? No. So let me return to the compilable version.
Okay, question. Why do we have to use a separate function if we can use just count in the code immediately?
What do you mean?
Like you can, without, okay, there's 3 lines.
You mean why I do this function instead of, see, I do that to compare like this.
Okay.
If it was my actual program code, I would probably not have a file or not have a function array. But again, it depends on the goals of the program. So and now let's look at the already known function accumulate. But that's a little bit different. So again, we take first and end. We take initial value 0. But what's this? It's a new function. What's this function? Yes, but where is it? It's on top. So it's my function. It's not some standard library function. It's not some whatever. I declare this function. I'm immediately using it in functional way, right? So the idea is that this function, let's look at it. What does it return?
If it found
An integer, but actually it kind of returns. No, it still returns an integer. So it takes accumulator, and it takes our every char in that file, right? And checks if that char is equal to new line. It increases accumulator by 1. Otherwise, it doesn't do anything to accumulator. So you have 90 seconds to discuss what exactly this binary operation does and why it's there. And then I need a short, concise answer. So let's do that.
Yeah, it increases it as it has.
No. Discuss.
I mean, it basically
So yeah, also
account.
wants to.
Yeah, like essentially it ends up just counting the new lines.
В смысле, когда мы принимаем decision, он может
Because we're learning what it does.
себя.
Which one? So checking line is in accumulate. That's a good way to think about it. So let's see, what was the previous accumulate?
Okay, so what the idea is? How exactly check new line is used in accumulator?
So this function works kind of as a closure. So it basically captures the data which is inside the accumulate function and sends it to the function check new line. And the function checks if it's a /n. We increment the data from that closure or not. And then
Okay. Something without using words from censorship list such as closure and captures.
I'd say
That's all correct, but that's censored by two complicated terms department of ours. Yes.
Okay, so it takes the beginning of the file, it takes the end of the file, and just applies like binary function to every parameter that it takes. So
Yes. So what are the parameters that it takes?
it takes chars. So
It takes chars. What's then
Ack is like it's a variable that we initialize. in the
Okay.
function.
So Valentina?
See, I was going to go even further out, and I was just going to say it's like where the previous time accumulate was basically just using add, now it's doing the same thing with check new line.
So what it basically does, it applies our function check new line on its internal parameter accumulator. So remember, the function is called accumulate. So it has this internal parameter accumulator that is going to return initially. So remember, this function is a binary function, so it needs two parameters. So first one is that internal counter accumulator, and the second one is an every element of our vector, or in this case file. So, and what accumulate does, it does very simple thing. It's like, actually, I don't know whether I can open it here. Nikita, you know all the shortcuts, how to go to definition.
I think you press try Alt or Control and click on the name.
Let's see. Yeah, so it's kind of yeah, so that's what accumulate does. For starting from first and ending to last, it calls the binary operation on the. Yes, I know it's really scary.
Scary.
But what it does, it's called the binary operation on its accumulator and each element of this vector.
Oh, okay.
So, like, if I would like to rewrite accumulate, it would be basically like so. Again, it has int init equals to 0. And then I do for this. God bless auto. Of course. 2, and then I less than this. And then I++ probably would work. And then within I do check new line in init and I. Here you go. That's all what accumulator does. So it assumes that the function, the binary operator that we provide, it assumes that that operator will somehow change the init to initially return it to the user. So obviously, and if we do not provide check new line, so if we do not provide our own function, instead we will just do init plus equals I, and that's all. So that's what accumulate does, but it does it for us. And that's why we can provide our user-defined functions to accumulate, to do whatever we want. We just need to make sure that we increase that accumulate things that we get. But you can say that that is like defining a new function every time we want to do a for loop is kinda cringe, right? So what should we do instead? Well, instead we have this thing called lambda expressions. What's a lambda expression?
Anonymous function.
Anonymous function. So what does it mean, anonymous function? So the idea is functions that doesn't have any names. It's like wanted by FBI, and that's why it's hiding its name or something, right? So the idea is that actually lambda expressions comes from the concept of lambda calculus. So remember we were talking in SQL class that SQL is basically math in disguise. Well, this is also math in disguise. So there's this lambda calculus thing. Yes, I know, right? You're learning math and it's still not enough. I will petition the department to replace object-oriented programming with more math. So the idea is that lambda functions are functions that it doesn't have any names, and you can immediately declare them within your code. So let's see what this program does. So the idea is that we have some array of players. I don't know, imagine that we are playing some game. Who is the best person in existence or something. And this is the scores, right? So a pretty simple idea, right? And so the idea is that we want to print out the results of a player that meets certain threshold. So so we ask the user for certain threshold. Let me actually do that. So let's say that if a user reached a threshold of 90 points, we print their name. Something like this. Here you go, right? And if it doesn't, we don't print it. Okay, so how would you do that in regular way? I won't do that comment exercise because it's really short. So what would you do?
Iterate through the vector. Iterate through the vector and check each of them.
If a vector, you immediately print it. Great. So here, I will show you the functional approach. And like, so it looks, so there is actually two functional approaches. Let's start with the top one. So can you guess what std for each does? Std for each? So one of the ideas of functional programming is that another thing that is cringe is for loops. You should never use for loops because for loops is imperative. You tell exactly what increase and how. Instead, we are following declarative type. So we are saying for each element in our vector players, for each element in our vector players, we need to do this. What's this? Actually, what's all this? This is the lambda function. So we basically saying for each element of the vector, apply a function. So the idea is that we can write this function as a proper function with declaration and so on and so on. But since we do not want to litter our code with unnecessary declarations, we can immediately declare a function here. So, and I know it looks scary, but now let's quickly discuss what's going on, quickly because we are a little bit out of time. Will be soon at least. So the idea is that first, we have the things that tells the compiler that we are having a lambda function is this square brackets in front of nothing, right? So we have this, it means that we are declaring a lambda function. And what the square brackets means, they are something that Kobe already mentioned, that's a closure. So basically what it does, it captures, for instance, in this case, variable threshold from outside. So the idea, so it captures variable threshold from outside, and variable p is its parameter. Who can guess what's the difference between closure and a parameter? So what's the difference between capturing a variable from outside and a variable being passed to our function?
It can be reused.
So elaborate. What do you mean by it can be reused? What can be reused?
The inner function, you can access it and it stays like pointing at the same address in the memory, I guess.
So function can be reused.
The variable,
Which
Like,
variable?
For example, you change it, the function called one more time, and it is changed, and it will change one more time. And
So yes, exactly. So in this case, threshold will be shared between all function calls. So every time our for each function calls this lambda function, threshold will be shared between them. So the idea is that you can treat it as like a constant variable that's being passed to the function from the outside. So like every single call to that function will use it, and it will be the same across those. While p will be changed between function calls, right? So can you guess what for each does? It calls these functions with different values of
Player.
p player, yes. So the threshold stays the same, while player changes with every call for each task. So since players have 5 players, there will be 5 calls to this lambda function, and all those 5 calls will have the same threshold, but it will have different players. So obviously, instead you can do this. If you really want to, you can do const int the t, for instance, the trash. I cannot even write it. Oh my god, it's such a weird word. Here we go. And but now for each is like what I have. I'm expecting a function that takes only one variable, and you are trying to pass me a function that takes 2. So that's why closures are useful, because they are not kind of an argument based function. Instead, that's a thing that's being captured from outside. So the idea is that like if you were writing this function, this for loop itself, you will declare threshold outside of for loop, while you will declare p inside of for loop. So if you to write this iteratively, you will do for auto p in players, and then here you will do if p score, Come on, finish it for me. Thank you. So see, P is inside the for loop, while threshold comes from outside. That's why when we are writing a lambda, threshold is being captured while P is being passed as parameter. Here you go, and then after that we write the body of our lambda function. This is it. And then in this body we check if it's greater, then we print it. So you would say that this is shorter than this. Will you say this? And the question would be why to do that? Well, first of all, this is probably an impromptu example. There could be, so depending of how much your code you have your code, then it will change what's short and what's not. But also, since C++ 20, so that's like the newest feature, because C++ 23 is not released yet. Since C++ 20, they introduced this special namespace ranges that also has its own name, its own type for each. And for ranges, instead of passing begin and end, you just pass the entire array. That's basically the biggest difference. And then you still pass a lambda function, but here I have rewritten it so it's shorter. I use ternary operator, like this. And another thing that it introduced in C++ 20 is string format, this kind of thing. Can you guess what it does? Can you speak up, please? So it actually replaces each pair of the brackets within the string with whatever variable you provided. We like printf, kind of like printf, or kind of like f strings in Python. So with that, I can just do this, and then if I define this string somewhere outside, then it will be even shorter. But unfortunately, even though std format is C++ 20, my compiler version in CLine doesn't support it yet. It supports ranges from C++ 20, but not format. That's why it will not compile. But generally, there is even a shorter way to do this. But again, this is just a proof of concept to you, how you can use for each and lambda functions. And now for the last 5 minutes, so any questions about this? Okay. Then for the last 5 minutes of class, what does this function do? Discuss. Now I even gave you an additional hint. It says that output will be a sum instead of a magic.
Kind of generous. Which is the same thing as which? Like the first example? Yeah. But what is that? Like, what is it? So if n is greater than 5, it does something with the accumulator. Take a look at what the younger takes. What are the arguments we pass? Because that's where n comes from. Mm-hmm. Yeah. So I think if n, so if the number is real, so the first time it's not going to do anything because the number's 1. The second time it will because the number's 7. Because that's what's getting passed. Yes, that's what I think.
Let's have 30 more seconds.
I do know what it does. Yeah. You go work tutoring and not. I'm like, yeah. So what does it do?
So, okay, what does the function do? Not the function, the program itself. Yeah.
Takes the element and checks if it's just greater or equal than 5. If it is, it's just it sums the n multiplied by 3. And other way it does nothing to the common.
Okay, I want to hear the second opinion. Anyone?
Yeah, it just multiplies the number by 3 if it's bigger than 5. Otherwise, it just
And then it multiplies it by 3, and then it does what?
accumulates.
It sums, basically it sums all numbers that are greater than 5, multiplying them by 3 first. That's all. So you would say, so here you go. In the beginning of the class you were not sure what this program does, now it's quite easy. So one might say that it's actually not easier than what you already know, like the way that you already know. And I will partially agree to that, but only under 2 conditions. First condition is that all unknown syntax is weird, right? So the idea is that if I show a regular programmer like our good old, easily understood empirical average, they'll be like, what's this? I don't know, Ayana, do you know what this code does? Say no, say no. No. Here you go. See? See? And like the same is with lambda functions and functional programming. So you need to first to get accustomed to it, and then it becomes very intuitive. And another thing is that C++ is actually a language that's only adopted functional programming. It was not molded in it. It was not born in it. Who got the reference then? I think. Anyway, the idea is that there are programming languages that are specifically fully functional. For instance, Haskell or MATLAB or whatever, Julia or something like that. So, and because of that, obviously their code is much more concise and much more readable, again, to a person who understands the idea of functional programming. For us, if we are not embracing functional programming fully, I think that just really need to write things like this instead of this. Or another example was this std count instead of this weird empirical count. And it becomes even better with ranges, because with ranges, instead of providing weird iterators, we can just provide the entire array, and the work will be done for us. But obviously that's only scratching the very, very, very superficial layer, functional programming. And I'm not even talking about more weird and alien concept of array programming. Do you want to see a look at array programming?
Yes.
Like before I'll let you go. APL program example. So, oh yeah. So, let's see. That should be good one. Oh yeah, this one. This is, okay, this is a real programming language. That is, yes, I will share it in a second. That is really liked by some people. So I'm not I'm not inventing this. Look at this. This is not a pseudocode, it's a programming language. Or like, this is also a good example. Yes, so the idea is that array programming languages, they double down on the idea of, this is a low-res photo. They double, oh, this is the better one. Okay, this is another array programming language. Here you go, yes.
I've heard they built a separate keyboard to support this.
Yes, there is a special keyboard that supports all symbols. So the idea is that they double down on the idea of concise code, and like the code should be as short as possible. And again, there are people who claim to understand all of this, and for them, they say it's much more convenient to type one symbol that is really weird for us, but they know what it does, than write an entire loop in C++ or something like that. So obviously we are not going that, at least today. Maybe I'm actually have an idea of having a short session on something like this, maybe sometime in the future. For now, like what's practical for us is to know that maybe sometimes when you think about writing a for loop, think whether there exists a handy standard library function that will do that for loop for you, but much shorter. So thank you all for coming, and as usual, before I actually let you go, I want you to do